Okay, so today is a little bit of review of yesterday. I know with a reserve teacher, it's always good to just kind of review that briefly to make sure you understood what I was trying to get you through there. And it's all about arithmetic and geometric sequences. And so you are not, gentlemen, you are not, okay, do you need something? Okay, I'll pause for a moment. Okay, so I'd like you to get to this slide right here. All right, first of all, the first four terms. Well, the first term would be sticking in a 1. Well, given this direction right here, it tells me that I should start with 1. Do you get how it says greater than or equal to 1? So if I want to put in a 1, I just stick in a 1 here, and I figure out what the answer is. I would like you to make a list for me of the first four terms here. If you already did this before, awesome, but I want you to review it and make sure you understand what's going on. Here, I'll clean this up for you. You're sticking in a 1 to begin with. In a moment, I'm going to have you compare with the kid sitting next to you. I'll tell you who you're paired with right now. Just to get people started, in case you're stuck, you put a 1 in first, and you'll get 5 to the 1 minus 1 is 5 to the 0 over 3 to the 1. But you actually do that. And what's 5 to the 0? 1 over 3 to the 1, which is 3, so it's 1/3. Okay, that's how you're supposed to be getting these. And the first one is 1/3. Would you compare, please, with the person sitting next to you? See if we get the same thing. Okay, so 1/3 and give me the other two, or 3. $125 over 81. Okay, awesome. Now, do you get that you didn't just add something each time? Therefore, this was not an arithmetic. Okay, so what's the other kind? There's arithmetic and what? Geometric. This one's a geometric then. So if it's a geometric, what do we multiply by each time? Well, I can tell you this. Look across the top. How do you get the top part? Multiply by 5. How do you get the bottom part? Multiply by 3. So then it's just 5/3. And 5/3 is what you multiply by then. And that's called the what? Common ratio. All right, learn some terminology here. Common ratio and common difference are the two things that go with geometric and arithmetic. So which one goes with which one? It makes some sense if you think about it. The arithmetic one is just a simple adding one, okay? And that is a difference between the two numbers, right? So it's common difference for arithmetic. And what is it for geometric? Common ratio. Good. Okay. So now this one is just written differently. It's a very similar problem. It's just that instead of saying n is greater than or equal to 1, it says this. Do you get that that means the same exact thing? You start with a 1 and you just keep going until infinity, but obviously you don't have to go to infinity. It says do the first 4 of them, but okay. So it's just a different way to say it. All right. Everybody turn your iPads my way right now. Okay. Thank you. Just wanting to make sure who's with me and who's not. All right. Thank you. Is there a reason? I'm not seeing where you are. Is there a reason? All right. Okay, here we go. I want you to now get to this slide. And that one is for arithmetic. Memorize it. You'll need this formula. It's going to be very handy. Okay? And then the other one is for geometric. And that's right here. And that's this formula. Now let's go back and talk about them briefly and show you the difference between the two. On the arithmetic one, you start with, and I wish this kind of had a sub-zero in the formula so that it would be like the original one, okay? And that's where the original term would go. So if I had a simple one, like let's say I'm starting with 7, and I'm adding 10 every time, it'd be 17 and then 27. Do you get the pattern there? Okay, so then in this formula, what could I put where? A sub 0 is what? 7 plus n minus 1 times d. What the heck is the d? Common difference. What is the common difference? 10. And then I could put a sub n right here. Do you get this is a lot like saying y equals some variable has something, something, something that has an x in it? It's just like an equation like that. This is an equation that'll help you to find whatever term you want. So let's say I want the 33rd term. Yes, sir.
So yesterday when you explained this to us, said that you'd rather it have an a sub 1.
Instead of an a sub 0, I gotcha. Yep. And I could agree with an a sub 1 or an a sub 0. It all depends on what you want to call your starting term. Because if you call your starting term 0, it can be confusing because then if I say what's the third term, it's actually n equals 2. See what I'm saying? So I hear you that 0 can be confusing that way. But in a real world situation, do you get starting at 0 makes sense? Because then you can say at time 0, I had this much money. Like I started my problem with this much in the bank. So starting with 0 or 1, it really does depend on what you want to do. Okay, so now, given this problem, what if I wanted to know the 10th term? Let's keep it simple. The 10th term. What do I put in? I put a 10 in for what? n. So I'm finding a sub 10. That's the 10th term in an arithmetic sequence is a sub 10. Does that make sense? And then what else needs to become a 10? The m that's over in the formula there. There we go. Do you get that? All right, so then solve it. Tell me what the 10th term is. Well, a sub 10 goes actually here. What is that number? Well, I got to figure out what this other side is first. 7 plus 10 minus 1 is 9 times 10. 9 times 10 is 90. 7 plus 90 makes 97. Raise your hand if you had 97. Okay, good. All right. Do you get how you could use this same exact formula to figure out what you're actually adding? I don't know what the common difference is, but I know the first term is this, and the fourth term is that. Figure out where you could take these, put this information in, and what you could solve for, and figure out what is the common difference, and therefore, what are the other two? And don't just do it in your head and go, oh, I can tell it's just like 17 and 27. Okay, I want you to actually solve this thing and figure out what D has to be by solving it. In fact, I'm so scared somebody's going to be doing that. I'm going to change this to a 42. That way, I know you're not just going to like, oh, I know the numbers from before. Okay, your first term's 7. Your fourth term is 42. How could you use that in this formula right here to figure out your D, your common difference? Well, I'll give you a hint. Stick the 7 and the 42 in the right places carefully, and you'll get it. I'll pause for a second while you figure that one out. Figure out that you were adding 12.2 each time.
No.
It was nice having people going, yeah. No, it wasn't. Okay. So, how do you get it? Walk me through it. Oh, go ahead. I got a volunteer. Yes, that'd be great. Tell me what to do.
Yeah, put everything into the.
I like it. Put stuff where does the 7 go?
You put the 42 at the AN.
I can do that. 42 goes here, and then what?
And then equals 7.
And that's a 7. All right. Plus.
4 minus 1.
Why did you choose 4 for the n?
Well, because it's 42.
All right. Can't argue with that. The 42 is the fourth one. Yes. It's the fourth term.
Times D, and then what you gotta do is minus 7.
Okay, so we're going 42 equals 7 plus 4 minus 1 is 3D, and you're subtracting 7. So then you get what? 35 equals 3D, and then what do? You divide by 3 on both sides, and you get 35 thirds. Yay, I figured out D. Fine. Okay, so it's 11.6. So, okay, fine, it's 11.6 repeating. 11 and 2/3. So what? Well, now we can figure out the second and the third terms. How would you figure out the next term then? 7 plus 35 thirds, right? All right. Let's do a problem just like that, except with geometric. Okay, so if I have a geometric sequence and it's like 4, and then I'm going to times by 3 is 12, and then I'm going to times by 3 is 36, except if I, for instance, left out this part, said, oh, I don't know what that is, I know you could now know that it's times 3, but tell me, see if you can figure out how you could stick those numbers in and figure out that it's times by 3 each time. Oh, it's not bad. You can do it. Not that, it's a whole different question. An even better question might be, am I actually here right now? Are you actually floating in a jar somewhere? In a scientist's experiment? He's manipulating your environment to make you think you're here?
Yeah, what if people are watching? What if aliens are watching?
It's okay. All right, so do you have the 4 in for the a sub 0? That would have been smart. Okay. Do you have the 36 in for the a sub n? Excellent. And that depends, oopsie, 36, not 34. That depends on which term it is. And by saying that a sub n is 36, you get that we're saying n has to be what? N has to be 3, because that's the third term. So then if n is 3, I stick a 3 there. And I'll have 36 equals 4 times r to the 3 minus 1, which is 2. Now what? Get the clump alone. That's the clump. We're going to divide both sides by 4. We get 9 equals r squared. So r must equal 3 or negative 3, interestingly. But we can call that other one an extraneous answer. I know that's kind of just cheating, but I'm going to. So r equals 3, and therefore, what do we figure out? The radius is 3? Oh, the common ratio is 3. Okay. Yep, square root, and yes, it's absolute value r, and yes, technically that means plus and minus 3, but I threw out the negative because it was extraneous. All right, so let's go to your actual homework for today and see what those are like. All right, did you get that last night's homework, you were supposed to do the entire front page? Okay, good. Then did you get that on the next page, you were allowed to just do number 11? You were told to do both? Okay, all right, I believe you. And just to make it fair to the other classes, I mean, because they didn't have to do 13. You guys are not going to have to grade 13 when we grade it, which is not going to be today. I'll be putting the 2 assignments together and grading them both tomorrow. All right, this one was assigned, but this one was not, right? Okay, good. Then, from here, I assume those weren't too tough for you. I hope your homework was fairly easy. Okay, good. Then moving on to the next stuff, we can talk about the next part of the assignment. I'm going to have you skip 25 and 26, but do 22, 23, 24, and 27. So let's do one of these together. Okay, 3, 5, 7, 9. Seems pretty easy. We're adding 2 each time. So can you tell that that's the arithmetic kind? If you have it memorized, try not to cheat. Write the arithmetic formula here, and I'll give you a hint. Both formulas start with a sub n. You can dream that they'll be that simple. Maybe you'll have an R2, like number 1, the very first problem on the test. It might be that easy.
Add one.
If the question only is, well, here, it says, find an explicit formula for the nth term of the given sequence. See, this isn't just like find me the third term. That'd be easy in your head. But do you get that the formula is this formula? A sub n equals a plus n minus 1 times what? D. Now, is that a good answer? No, that's not for this situation. That's for all situations. So now we can just change this to fit this situation. Mr. GK, tell me, what in this formula do we know from looking at this? Okay, the initial one is 3, and I put it where? All right, I'm put a 3 right there. Now what? We know D, just be able to, like, it's so easy to do in your head. So how do you get D in your head? Do you get how we're just adding 2 each time? How could we have gotten that if it wasn't that simple? How do you find a common difference if you're too complicated things? How do you find them? Yes. Yeah. How about, I don't mean that complicated. I mean, like, I give you a 3 and a 5, and I say that they are for sure, like, you have figured out that it's consistently adding each time. What do you do to the 5 and the 3? Yeah, you just subtract them. You take the second one minus the first one, so 5 minus 3. So instead of, just understand why I'm not just slapping a 2 in for my D, even though I know the common ratio is 2. I'm showing you how you're going to do it when you get to the tough ones. You take this one minus that one, 5 minus 3. And I know it's 2, and yes, on this easy problem, you could do it in your head. But what if these were, 3.927 and 5.643, and you know what I mean? You won't necessarily know for sure exactly what the common difference is. So you take the one minus the other. Okay. All right, so there is a formula. Do you get how it still has a letter in it? And that's okay, otherwise it wouldn't be a formula. See what I mean? A formula is supposed to have a letter in it. It's supposed to have a variable in it. Okay? All right. So you can I think you'll be able to handle doing all of those. Number 27 will stretch you a little bit because it's got variables in it. So again, do you just know off the top of your head exactly what to add each time to make that happen? Or what to multiply by each time to make that happen? All right. So then you're going to have to take this one and minus that one. Or what if it turns out that they're multiplied? Yes, you'll take this one divided by that one. Notice you always take the second one and divide by the first one. Or you could take this one divided by this one if you'd rather. Or you could take that one divided by that one if you'd rather. Okay, looking at that problem, is it adding the same thing each time? Number 27? No, and therefore it is not arithmetic, and therefore it must be geometric. Okay. So, this one is a good challenge question. This one you do not have to do. Go through it with me here and cross off the ones you don't have to do. I didn't mean to say you don't have to do 31. Do 31, and it is one of your more challenging questions, but it's not a optional skip it challenge question. Do it, figure it out, and you all know you have answer keys if you need to refer to them, but don't make yourself mentally weak by looking at a problem for 10 seconds and going, don't know it, gonna go check the answers. You will make yourself weaker and weaker at solving problems if you do that. Yes? Could you shut the door? Okay. Oh, so it's actually got an AP Human Geo tie. That's kind of cool. Awesome. Now, we have assignments and like smartboards that are very rich with lots of cool stuff so that if we have the time, we can do them. Sadly, we do not have the time. I have so much, like today I got the top 20 we could grade in class, which we probably won't have time for. We've got and that is for the coins, so that'll be interesting to you when the time comes. And we've also got your other test that I already did grade. You got it done when I was here on Tuesday, and I got those graded while I was gone. And so anyway, we got so much to do. So even though this looks like it would be really cool, time is, it's just a factor we got to deal with. Okay, go to this one. Does it say here if it's arithmetic or geometric? Does it say in number 2? No. But can you look at the problem and quickly tell what's happening?
Yeah.
Good. Do you know it's arithmetic?
Yeah.
Do you know that -4 is an important thing, but you might not know its name? But do you know its name?
Yeah.
What is it? And the -4 is the common difference. Okay, good. So then find the 10th term. Do you get how the formula for this could be handy? I don't want you to just go -4, -4, -4, -4. Okay, that's the way a 4th grader could solve this. You are at high level math now. So you would take the formula for it, which is a sub n equals, remember it, without having to cheat and look, a plus n minus 1 times d. Very good. Okay. So then, if we want the 10th term, what's n? If we want the 10th term, what's n? 10. Okay. And then what's the common difference? We figured it out already. Do you get how I could have gotten the common difference? By putting 4 minus 8 right there? You know what I'm trying to say? Common difference is that minus that. And that gets you -4 for an answer, but all right. And n is 10. And from there, you can solve it and figure out the first term must be 8, so I'll put the 8 right there. Solve it out and you'll have your answer. Okay, good enough. Number 8. I messed up on this one in last hour, so I'm going to see if I can help you with number 8. And I'm going to actually, I think I'm going to just get out of the way and let you guys show me how you think it could be done. And I'll help you if you need it. But do you get it says it's arithmetic? So let's start with the formula. What's the arithmetic formula again? I just had it written down there. A sub n equals a plus, that's the original amount, plus n minus 1 times d. Okay. Now, did they tell me d? They did not tell me d, but we can figure it out. Did they tell me n? Okay. Now, one more thing that really messes with your head in this formula is because get our formula, no matter what the problem says, the formula has an n in it. Do you get that we happen to have n's in our original problem also? And those n's could have been p's or q's or w's. Pick a different letter. We want to change that n to something else, otherwise it'll get really confusing. Do you get what I'm saying? This is the formula for all. This will work for all problems. This problem happens to have n's in it. That is going to make it more confusing because you're going to think that n is the same as this n. They're not. So do you get that n could have been anything? Pick a different letter list that we can try right over the top of our n's. X's. I like it. Everybody could please put in an X over the top of your n's. Because otherwise you're going to think that the n in the formula is the same as the n in the problem, and there's no reason that it has to be. The n in the problem, it could have been any letter. Okay, so we're going to say x plus 5, 2x plus 1, 4x minus 3. Our 3 consecutive terms. Find n. We have to change that to an x now. Do you get that?
Are they the first 3 consecutive terms?
That's a good question. It really doesn't matter if they're the first 3 consecutive terms, so why don't we just think of them as the first 3 consecutive terms? Okay? Okay, so what could go where? What do you think? Could you put x plus 5 in place of a? I don't see anything wrong with that. Does anybody see anything wrong with that? It is our first term. It just happens to have an a in it. Okay, I don't know. Maybe, unless you see a reason why we can't. Stop us now if you see some reason we can't do that. But I think that seems reasonable. Okay. So now, a sub n. Do you get how that's like a later term? This is the first term. This is like a later term. Do we have to pick one or the other of our two? Well, we have to pick one of them. I'm just saying, is there a certain one we have to pick? No. So which one do you want to pick? 2x plus 1 sounds fine with me. So we're going to replace this with one of the other ones, 2x plus 1. Do you get by doing that, we just determined what our n in the formula has to be then? 2, because you picked that one, which is our second term, so n must be 2. A lot of things are simplifying out here. What can we solve for now? The common difference. Let's do that. So, if we solve this down, we say 2x plus 1 equals x plus 5 plus, 2 minus 1 is just 1, so that's just 1d. So then I have 2x plus 1 equals x plus 5 plus d. And, oh, wait a minute, wouldn't it be even smarter if we just got d some other way? Do you remember before we always just knew d because we knew that it was like 4 going up to 8 going up to 12. We just knew it. And I was saying we aren't just going to always know it. How can we know d? Would you agree that that minus that, if it's arithmetic, would give us d? Now, why aren't I using this minus this? Because then everything's going to cancel because I already used them in my equation. Do you get what I'm saying? I used the x plus 5 and I used the 2x plus 1 already, so I need to use these two. That one minus that one for my d. So this is plus 2 times d, and my d is, what was my d again? That minus that, 4x minus 3 minus 2n plus 1. And I better put that in parentheses, otherwise I'm just going to be subtracting the 2n, and that's not what we're trying to do. We're subtracting that whole thing. Just look at this for a second and try to understand what just happened there. Our d right here just became that. Oh, sorry. This is just plain me making a stupid mistake. Thank you. 2 minus 1 is 1. Thank you. There's a 1 there. Do you get at the end of it all, it's find x? Do you get how I have an equation now? And this is supposed to be an x. Dang it, that's supposed to be an x. We changed n's to x's because we knew that that n would be a nightmare, so I apologize. Okay, so now 2x, blue on blue doesn't work. 2x plus 1 equals x plus 5 plus, okay, I'm going to put all this together now. And 4x minus the 2x gives me 2x. And the negative 3 minus the 1, notice me distributing this negative. Negative 3 minus 1 is negative 4. And then it's 2x plus 1 equals 3x plus 1. Wait a minute. That's going to be weird. So then I'm going to subtract 1 from both sides. And it'll be 2x equals 3x. What? I'm not saying it's wrong. I'm just, okay. So how do I get the x's onto the one side? They got to all be together, right? So how about we track 2x? And I get 0 equals x. X equals 0? Could that be right? Well, let's look up at the original prop. If I put in a 0 right here, it'll be 5. If I put in a 0 up here, it'll be a 1. And if I put in a 0 right here, it'll be a negative 3. What happens if you go from 5 to 1, and then from 1 to negative 3? Negative 4. It's a really arithmetic sequence where it's actually, if x is 0, which is what we just figured out down there, if x is 0, then it really boils down to 0 plus 5, 2 0 plus 1, and 0 minus 3, which are really a 5 and a 1 and a 3. So our D was really negative 4. Let's see if our D being negative 4 kind of matches up with the rest of this. If you're saying then, Mr. Server, that D is negative 4, so it's like you subtract 4 to get from here to here, right? So then do you get, if I do 2n plus 1, and that could be any letter, we change it to an x, I could call it a p if I wanted to. You're saying that 2p plus 1, and then you subtract the other one, p plus 5, will lead us to think that 2p plus, the plus 1 and the plus 5 will make plus 6. This will be p plus 6. That difference, p plus 6, has to be the same as this difference. Okay, it's going to take me too long to go through it, but it will be, it will work if x is 0. Whew. Okay. I know, not easy. Let's backtrack. What did we do? We started with the formula. Then what do we do with the formula? We stuck stuff in. We stuck in our original amount and one of our other terms, which we could pick. And since we picked the second term, we had to use a 2 there. Then we figured out our D. Our D was our common difference by taking one of these terms and subtracting the other term. We just needed to make sure that would work the best if we subtracted these two that were different than the ones we had used in our original. I don't think you would have had to have done that, but it's just not a bad idea to do that. All right, yes? There is a different way that is faster. Can you explain it quickly so that we can go on?
Okay, so I solved for the n plus 5 being the first term, and then I solved for both the 4n minus 3 and the 2n plus 1, and then I made them equal to each other.
So you're saying if that minus that has to be equal to this minus this. Is that what you're saying? No. Okay, that would have been a good way, but what did you do?
I did
Okay.
What I did was I did the 2n plus 1 equals n plus 5 and 2 minus 1d and solve for d.
All right.
And I did the same thing with the...
I'm sure that bottom line, did you get the same answer? Cool. I do need to move on given how much time we have, and there is more than one way you can do these. The way I can kind of tell you that we can replicate fairly easily is just start with the original formula, plug stuff into the original formula. All right, move on, and the way I showed you is not the most elegant way. Okay, there are better ways even than I just showed you. All right, let's look at this one. You are assigned problem 10 and 11. And then you are going to be doing also 5 and 7, and then skipping the very last one. So you only got to skip a few in there, but these aren't incredibly hard. Let's do number 5 together. Number 5 is a geometric. It's a lot like what we just did, except we got to use a different formula. Try from your memory banks. Remember they start the same way, a sub n. You remember the geometric one? It's got an r in it. Who can do it without looking, without cheating? Yes, sir, Mr. H. to the n minus 1? Raise your hand if you agree with him. Okay, good. So then, let's stick in some stuff for this problem. At least they used a k, which is not, nothing in our formula has a k in it, so that's going to work nicer. Okay, so k plus 4 is our first term. Where can we put that? Yes, a0. So I'm going to drop in right here a k plus 4 times r. Do we know the r? Kind of. We can figure out the r. How could we figure out the r? R is the common ratio, right? So what's that come from? Yeah, dividing. Dividing like what? I like it. K plus 20 over 5k plus 4. Okay, that's the r. Now what's n? Well, we've got that n depends on what we pick for this. So what do you want the a sub n to be? It actually could be 5k plus 4. This one was the original one. We started with that one. So we can pick a sub n to be either 5k plus 4 or k plus 20. But since we just used k plus 20, yes?
That one is just, wait. Okay.
This one's just the starting term. This one's the r, which we got by taking this divided by that. Okay. Now, our n minus 1, we don't know what the n is until we pick our a sub n. So, which a sub n do you want? Do you want to use 5k plus 4? Or do you want to use k plus 20? And my advice is, from what I found in the other class, it can be confusing sometimes to use the same exact ones. So maybe we should use this one. We haven't used 5k plus 4 yet as our a sub n. 5k plus 4. And the nice thing about that also is that that means we pick the second term, right? So n is 2. So then we have 2 minus 1. So that means that's just to the first power. So 2 minus 1 is just a 1. Do you get why when I picked this, it forced me to use n as 2 because I was using the second term? Yes? Well, in the formula, so far I'd put in the first term. I guess there is a k plus 4 right there. You're right. I'd used it in the set. Yep, you're right. I hadn't used it. I want it from here to here for this part. I want to go from here to here for the other part. These two numbers, I'd like them to be the first and second term. And then this one, for the r, I used the second and the third term. Okay. But you're right that I had used it before. So, okay. So 5k plus 4 is equal to k plus 4 times 5k plus 4, and it's all to the first power. And now, we can do a little canceling, and eventually we got to find k, right? All right, is there anything that I can just multiply everything by and it makes it all better? It will help. So I got to go 5k plus 4 times 5k plus 4 is equal to k plus 4 times k plus 20. Because when I multiplied by 5k plus 4 here and here, this side was the complicated one, and this side things actually made it a little easier. When you're done, you're going to go to k squared in your problem. That's a quadratic, and if you can factor it, you should. And if you can't factor, quadratic formula. All right. Okay. I love how when I get it to this, I can just say, oh, so it's just that? Solve it. That's why you have to be good at algebra to be able to have a chance in this class, because you can get down to complicated things as your final, like your easy part. Okay. there's the first term, the second term, and the third term of a geometric sequence. Oh, and a fourth term. It even talks about that. Okay. What you're trying to figure out is if the sum of the first and the third, that's this one and that one, add up to 40, and the sum of the second and the fourth add up to 96, and you know it's geometric, then you can figure out what these terms are. All right, let me give you a hint. If these two things add up to 40, and we want to call this x, do you get that the other one would have to not be x? 40 minus x. Good. That's like my first and my last term, and I got to figure out what x is, though, right? Do you get that that formula might come in handy in solving this? So what's that geometric formula again? A sub n is equal to a sub 0 times r to the n minus 1. And what do I have? I don't know my common ratio. I'd love it if I did, but I don't. But I do know my original term, and I can stick in one of my other terms, like the third term there, and say n is 3, and then I'll be able to solve for the common ratio. All right, these are not supposed to be easy. If you were supposed to be masters of this, then we'd be testing tomorrow. We're not. So that's all I have for you for the new stuff for today. And I will give you back your tests now.